All right, number. Okay, now before we. Oh, hello, testing 1 2.
Hello?
Is there like an echo?
Can you hear me better now?
Testing. Yeah. Okay.
Okay.
All right. So when you do identities, you have to memorize this chart. Let me give it to you. This chart is in 7.1. You have to know these, or else you really can't do identities.
Yeah.
This one you should know. They're just reciprocals. This is a reciprocal. This one, do you know this one right here?
I don't know. Yeah, I'm not sure about any of those.
Okay, you have to know these. Like, there's
Okay.
no way you can do this without it. So sine squared u plus cosine squared u will always equal 1. And what you have to do is recognize the form and also like the variations. Like you can move these around. Like for sine squared u, you can subtract cosine to both sides, and it'll become something like this. Do you see that?
Okay. So that's
I
the same
subtracted,
thing.
yeah, that's the same thing. Well, so that means if you saw this in your identity, you can replace it with what?
With the sine squared u.
Yeah, and vice versa. There's times where you want to replace this one, or you want to replace what? That one. Okay. So memorize, you have to memorize this. And then this one, okay, 1 plus tangent square u plus secant square u. And it has to be squares. It can't just be like 1 plus tangent.
Okay.
And you want to memorize it by saying things like when you get a tan for 1 second, okay? Okay, getting a tan for 1 second. And then also like the 1 and the letter T will always be together on the same side. You see that?
Oh, okay.
And notice right here, see how right here? 1 and T again. One's
Yeah.
always with the side with the letter T in there, okay?
Okay.
And so this last one, cotangent, the cos hang out together, cotangent, cosecant. And then you got your cofunction identities. You want to memorize these, okay? Now this is just the flip side of it. So sine and cosine always work together. Tangent, cotangent, secant, cosecant. So if you see this format, and this is like in number 27, if you saw this, you would rewrite it like that. So again, if you saw this in your identity, unless you memorize this, you wouldn't know what to do.
Yeah.
So yeah, so you have to replace it with these guys right here.
So they're reciprocal, right?
Yeah, they're equal, yeah.
Okay.
And then lastly, the even and odd identities. I'll explain this as we get there, but you want to, these two are the most important one right here. If you memorize those two, you can kind of reason out the rest. Because cosecant is similar to sine, and secant is similar to it, cosine.
Sorry.
Okay, so we're going to refer back to this chart as we go through this. All right, now you're looking at this and thinking, what in the world? Well, let me give you some side notes to just kind of help you see what's going on. So basically, you're going to be doing a lot of algebra stuff. Like you'll see things like two fractions with different denominators, like sine theta, cosine what? Theta?
Cosine.
Yeah, and so mathematically, anytime you have two fractions, you want to combine into one what? One fraction where the common denominator is sine theta, cosine what?
Cosine
Theta. And then the equivalent fraction, you'll put cosine theta plus what? Sine theta. You also have situations where you'll factor things out. Like if you have like x squared plus x4, well, what would you factor out for this one?
The x squared.
Yeah, so this will be 1 plus x squared, right? But instead of using x's, they'll use sine, like trig notation. So this will be like sine squared x plus sine 4x. So what would you factor out?
The sine squared x.
Yeah, and this will be 1 plus sine squared x. Okay?
Okay.
And then you'll just start like substituting. There's that one. And then there's also things like situations like this where in one fraction, you'll have like cosecant squared theta times like cotangent theta, or something like that, right?
Okay.
And you're thinking, what can I do with this one? Well, if you move the cosecant down, wouldn't it become sine squared theta, right?
Yeah, because it's the opposite, right?
Mhm. And cotangent, can't you like unwrap it and make it into cosine theta over
Sine.
sine?
Yeah.
You get it? Sine theta? Yeah. And then notice the bottom, you can multiply those two together and that'll become sine cube what?
Sine cube theta
Yeah. So basically like this has now turned into what?
into that.
To that. And so you're going to be seeing a lot of this situation. Keep this in mind. You cannot move identities up and down the fraction bar if there's like a plus sign in between. Like if you had like a cosine theta plus sine theta over tangent theta, you cannot bring this to the bottom.
Oh, okay.
Okay. You can only do that when numbers are all being multiplied to each other.
Okay.
Now, if you have a situation like this, cosecant theta plus sine theta all over cosine theta, and you're thinking, well, can I turn this into 1 over sine theta? Yes, but you cannot bring it to the bottom. You can go like this.
It stays on top.
Yeah, like this. You see it?
Yeah.
Yeah. Okay.
Okay.
All right. So here, now, generally, you want to start, as I think Ms. Town said this, start on the more complex side and work your way to the easier side.
Yeah.
Or work on the highest power exponent to the lower power exponent, right? But in this case, they're like almost identical, huh?
Yeah, basically the same.
Okay, so what you do is just start on one side and you realize, wait, I don't have any sine 4 alpha theorems to use, but you realize they're the exact same thing. You can factor it out. So some of these, if you ask like, how do I start these? You do what you can mathematically. So here we can factor. So we're gonna go sine squared alpha 1 minus sine squared what? Okay, do you see what I did?
Yeah. And then does the 1 minus sine squared, does that reduce to anything or does it just stay the same?
Okay, we don't want to say it reduces to anything. We're asking, is this equal to something else? Well, remember this?
Yes.
Sine squared u is equal to 1 minus cosine squared u, and vice versa. Cosine squared u is equal to 1 minus sine squared what?
Squared u.
So what can I replace this with? Cosine squared x. You see that?
Okay.
Now the question is, why did I do that? Well, you want to keep your eye on the other side that you're headed. Everything is cosine, so we have to replace this with cosine, right? So we replace this guy with cosine. What about this? What is this going to become?
Sine squared u 1 over cosecant?
No. Well, cosecant is not cosine. You want to keep it as cosine. Look at the Pythagorean theorem identity again.
So 1 minus. Would it
Sine
be
squared u is equal to what?
1 minus cosine squared u?
Wait, do you get it? We're getting it from this guy?
Yeah, so sine minus
So
squared.
yeah, I'm taking that and moving it to the other side, right? So this is going to become 1 minus cosine squared alpha. Okay? Now, you're keeping your eye on the right side. You're thinking, okay, is it looking like that yet? Well, watch what happens. Well, what can I do mathematically at this moment? Well, do you see that there's a distributed property here? This times that.
Oh, yeah.
And this times that. And if you distribute it out, what do you get?
Cosine squared minus, or cosine squared alpha minus cosine to the 4 alpha.
Yeah, which is just like what?
The same thing as the other side.
Okay. Now, not all of these work out like that. Some are going to be really long. Some are going to be super what? Super short. So you have to ask, what can I do mathematically, algebraically, to make it look like the other side? Now, okay, so look at this guy. So again, try to understand how I'm reasoning this, because it's not like I know everything offhand just by looking at it. I mean, I've done this enough, but when I look at these, you could start in several different ways. You can start on the left side or the right side and vice versa. So you're thinking, okay, what do I do here? Well, this is what I'm thinking. On the left side, I see one fraction. Do you see one fraction?
Oh, is it the 1 over?
Well, it's just a fraction like this.
Oh, yeah.
Yeah. And on the right side, how many fractions do you see?
None.
No, one.
Oh, okay, one.
Everything is a fraction, right?
Yeah.
Second, what do I notice? Well, this one has a squared. See it?
Yeah.
But there's no squared over on this one.
On the other side?
Yeah, because look, when I see a cosecant squared theta, my mind immediately goes to this identity. See this?
Okay, cosecant squared theta. Okay.
But the real question is, should I replace cosecant squared with this? Like, you see this?
Yes, because then you can like cross it out.
Well,
Or no?
no. You shouldn't. Watch. If I do that, what was it again? 1 plus cotangent squared theta, right?
Mhm.
Now, if you take this and replace it with that, notice that the squares still exist, right? Oh, wait, you can't do this. Remember I told you, you cannot cross these out when there's an addition sign.
Yeah.
So, yeah. So again, if you did this, okay, can you do this? Yes, but should you? No, because look at the right side. There's no squares, but there's another square right over what?
On the
Here.
other side. Mhm.
Okay, so you're thinking, okay, is there another way? Yeah, there's always another way. So instead of doing that, how about let's do this. Let's split the cosecant into two, like cosecant theta, cosecant what?
Okay, cosecant theta, cosecant.
And then let's see. Let's just keep like unpacking it, like making it as simple as we can. So cosecants, I'm going to bring it to the denominator, and this will be like sine theta, sine what? Do you get that?
You said that's from.
I brought the cosecant to the bottom.
Oh, because it's 1 over. Okay.
Yeah.
And then did you keep the cotangent like how
Well,
it is?
so I'm going to take the cotangent, move it back to the what? To the top, so that this will become tangent what? You see it? Okay, so you have to know how to do this. I mean, you have to know that you can do this with trig functions. When you have a fraction, you can move those numbers, as long as there's no plus or minus sign, you can move it up and down the fraction bar. So cotangent, if you move it to the top, converts to a what? Tangent.
To a tangent. Mm-hmm.
Yeah. Now, okay, so, oops. What else can we do? Well, do you notice that tangent is sine over cosine?
Tangent is sine over cosine, yes.
Do you see what I just did right there?
Oh, okay, I see. So
when you cancel out a sine.
Okay.
See that?
Yeah, so it'd be 1 over sine over.
Yeah, and isn't that basically cosecant secant? If you move the sine and cosine back to the numerator, what will they become?
This numerator. So it's sine times cosine, right? So it'd be.
Look. So I took sine and brought it back. I moved it to the top again. Right here.
Wait, why would you move it to the top? Is it because?
Because I'm looking at the other side. I need a cosecant.
Mm-hmm. The cosecant is 1 over. Wait, sorry.
Cosecant is 1 over sine.
Okay. Okay, so it goes to 1 over and then sine. Wait, sine over sine. Okay, and then you said to move it up because it's 1 over sine. Okay.
Here, I'll rewrite this one more step. I'll put one more step on this one. So this will be 1 over sine theta over cosine what?
Cosine theta.
Yeah, and then bring the sine and cosine back to the numerator, and they'll become cosecant theta and secant what?
Secant theta.
Yeah, which is exactly what the other side has. So your goal is basically to make it look like the other side.
Mm-hmm.
Okay, is this pretty confusing?
Yeah, it's confusing to me just because it's like you move it up and then you move it down and then you have to like move it back up. I feel like I just lose track of like the way it has to move, I guess. But I just need to remember. I think on the test, I'm gonna like write down like even the simple ones so I don't mix it up. Because I think I need to like visual to do it.
Okay, so it's about writing it. Okay, so the question is what's allowed in terms of rewriting the trig function? So when you have sign like this,
Mhm.
yeah, are you allowed to bring this sign to the bottom?
Only if it's being multiplied.
Yeah, well, I mean, like right now, it's just by itself, right?
Oh,
So if sine theta decide, you know what, let me go to the denominator, he will
Mhm.
change to a what?
Oh, to cosecant.
Okay, now, does that make sense?
Mm,
Okay, so this is where you're kind of getting hung up on, right?
yeah, I think so.
Okay, so look, what's sine theta? Sine theta is another way of writing it is 1 over cosecant what?
Cosecant theta.
Okay, do you get this part?
Yes, that part I
Okay,
can.
so that means on the left side, if sine is on the numerator,
Mhm.
I can rewrite it with sine moving to the denominator, but he'll change his form into a what?
Into the denominator
Into
or
a
to cosecant.
cosecant.
Okay.
Okay, does that make
Cosecant.
sense?
Yeah, it's just like the inverse kind of, right?
Yeah, the reciprocal. Okay, now what if I had this? What if I cosecant theta
Mhm.
on a numerator, and I wanted this back on the bottom? What would it become?
1 over sine
No,
theta.
no. Oh, so you're thinking 1 over sine? Just do sine.
Okay, so 1 over sine.
So this will disappear, and it'll become sine theta.
Would it be on the denominator or the numerator?
Denominator.
Okay.
Okay, so yeah, okay, so we ju- I we need to clarify this, and I think it'll become easier. So yes, this is you. I'm trying to tell you, like you can do it this way,
Yeah.
but I think you're thinking about it like this. It's like strictly like if you see a cosecant theta, you're thinking 1 over what?
Yeah, 1 over sine.
Yeah. So here, so if I put it like this, cosecant theta over, let's say, 4 sine theta, right?
Mhm.
Okay, so then does that mean that I have to replace this with 1 over like sine theta like that?
No, you could just put it on the bottom.
Right. So instead of doing that, okay, but this makes sense in your mind, right?
That's what I'm thinking of, I think.
Yeah,
Yeah.
okay.
Work,
So
right?
it's just an extra step of work. It's not
Yeah.
that it's wrong, but it'll make things really complicated if you keep doing it that way.
Yeah.
But so from now on, just tell yourself, if cosecant's on top, I can move it to the what?
The denominator.
Right here and put it like that.
Okay.
See that?
And then
Okay.
for the top, would you just leave it like blank or would it be 1
Oh, it'll be
technically?
1. Yeah, there's always a when there's nothing, there's always a 1. Uh-huh. You don't want to put a 0 there, or else it turns everything into a 0.
Oh, okay.
Okay. All right. So yeah. So yes, you this is the way you want to do it. It'll be much more easier, uh, as opposed to always rewriting it as like 1 over sine theta. So here, what about this? What if you had like a cotangent theta? Can you move it to the top?
Yeah, tan.
It'll become tangent theta. And then can you unpack it to its a more basic form?
So it'd be sine over cosine.
Right, sine theta over cosine what? Theta.
Cosine.
Okay. All right. So now that we know how to do this, we can go back and work with like, these fractions. Wait, so do you want me to redo this one?
Oh, that's okay. We can do the
Yeah.
next one. Get that
Okay,
one
let's
done.
try 13. Okay, so, oh my goodness. Oh, yeah. Okay. Now, here's a situation where you have to decide which side you're going to start off on. Now, generally, it's always easier to start with 2 fractions and combine it into 1. So if you notice on the right side, you have 2 fractions, right?
Yeah.
Okay, so the question is, should I start on the right side and work my way to the left? I can. Now this one, I think I can go both ways, and it'll actually be easier. But so watch this. Okay, let's start on the right side first.
Okay.
So now, if you want to go from the right to the left, keep your eye on the goal. You need a denominator of a cosecant, right?
Yeah.
But here, do we have a denominator of a cosecant?
No, you'd have to multiply cosecant, right? And
Yes, but watch. Can you convert one of them so that you end up with the cosecant on the denominator?
the second one
Right. So how'd you rewrite it?
would be, so you multiply cosecant to,
No, like this. Your favorite, right? Right. Rewrite sine t as 1 over what?
okay, sine t over 1.
Okay, do you see how I got that?
Yes, okay. So cosecant t times 1 over cosecant.
By the way, when is this quiz? Tomorrow?
It's on Friday.
It's on Friday? Okay. So Adeline's video will have the later half of this. Your video will have the beginning. So just use both. And
Okay.
it'll have almost every problem.
Yeah.
Okay, so do you see what I'm doing? I turned the sine into a what?
Into a cosecant.
Yeah, why? Because on the left side, I need a denominator of a cosecant on the denominator, right?
Yeah.
Now I'm going to take the two fractions and turn it into a common denominator of cosecant t. Okay, do you see why I'm doing this?
Yeah.
Okay, so the second one stays the same. What about this one?
So you flipped it over, or not flipped it over, cosecant t.
So this is, remember, there's a 1 here.
Yeah.
So if I need a cosecant t on the bottom, don't I have to multiply that to the top as well?
Yes, you'd also.
So this will become cosecant square t. Do you see that?
Mhm.
Okay. And then what do you do whenever you have a common denominator? You combine it,
Mhm.
and this will become cosecant t, and the numerator will become cosecant. Oh, I can't even write cosecant
Squared t minus 1.
t minus 1. Okay, now you're thinking, all right, the left side has a cosecant t on the bottom, but the numerator, how do I turn that into a cotangent square t? Well, do you recognize this in the trig identities? Look at that chart that I had you.
Oh yeah.
What is this equal to?
Is it the 1 plus cotangent squared?
Well, yeah, but rearrange it so that you'll see a cosecant square t minus 1.
Just cotangent squared.
Cotangent, there you go. So this is basically cotangent square t over. There you go.
Okay.
Aha, we got to the other what?
To the other
side. Okay.
Mhm.
All right. Now let's start on the right side. I mean left side and go to the right side. Meaning when you do these, again, it's not obvious. Like, okay, when I did this, you're like, I didn't know you can do that.
Yeah.
So there's a lot of different ways. Whatever way you start, eventually you'll get to the right answer if you just stick to the math. Okay, and that's the idea. So this one, you can actually go both ways. So let's imagine you're taking the test, you're like, let me try it on the right side, and then it worked. But then another question, you're like, would it work on the left side? Now on the left side, there's a little trick to this, and it deals with something like this. When you see something like an x squared plus 3x over 5, can you split this up into two separate fractions, like x squared over 5 plus 3x over 5?
Yeah.
Because if you put it back together again, it'll do that, right?
Yeah, it equals the same thing.
So now I'm looking at this, I'm thinking, wait a second, I see the numerator, I can replace that with my identity and then split the fraction into two separate what?
Two separate fractions.
Yeah. So watch this. Let me bring this down.
Is it the cosecant squared minus 1?
Yes. So try it. So replace the top with cosecant squared t minus 1, right?
Yes, and then
cosecant t, and then split the fraction. Cosecant squared t over cosecant t minus 1 over cosecant t. And guess what? What happens right here? You can cancel one of them out, right?
Yeah, and then the other one becomes sine.
Wow. Okay, isn't that cool?
Yeah.
Now the question is, which way was better? Obviously, this way is much what?
A lot faster.
Yeah, but the thing is, you don't know when you take the exam. Okay.
Yeah.
Now, when you do like hundreds of these, you can kind of see through it. You're like, oh yeah, this way will be faster.
Mhm.
But that's why you got to do a lot of these. So I told Adeline, practice the even numbers as well, so
Okay.
that because she's not always going to give you the same answers as same
Yeah.
ones as the odd numbers. So practice the even numbers and try both ways. You just have to learn different techniques.
Okay.
Let's try 15. Okay, now here, let me give you an illustration. So, all right, so remember factoring. Like if you see something like x squared plus x7, what would you factor out?
The x squared.
Yeah, the smaller of the two, right? And then this will become 1 plus x to the
5.
5. How'd you get 5?
Because you can add the.
Or 7 minus 2 is 5, right?
Oh yeah.
Yeah, or 2 plus 5 has to go back to what?
To the 7.
Well, what if it's a fraction like this? X to the 1/2 plus x to the like 4.
Is it
Well, you always factor out the smaller of the two exponents, just like this one right here, right?
yeah.
So this would be x to the 1/2 and 1 plus x to the what? Well, how do you figure out what to put right over here? It'll
Is
be
it
4 minus what?
4 minus 1/2?
Which is some fraction, right? You don't have to do it. Yeah. So look, this, now you're looking at this, you're thinking, where do I even start, right?
Mhm.
And you're thinking, okay, wow, what can I do? Well, first I noticed that the cosines are exactly what?
The same.
So you can factor it out. Now on the other side, just keep in mind, like the square root of x, that's just a fancy way of, well, you can write it like this.
1/2.
Exactly, right. So this is our goal. We have to get to that, this one term. So we're thinking, I don't even know where to start. So just do what you can do mathematically. In this case, you got common factors. So let's just factor out the cosine first.
Okay.
So cosine of x, and then this becomes sine 1/2 x minus sine 5/2 what? Sine
minus
5/2 x. Okay. Now inside the bracket, can you factor out a sine 1/2 x?
Yes.
Yes. So we're gonna go like this.
So cosine x.
Will that become 1 minus what?
Sine, or sorry, 1/2. 5/2 minus 1/2.
Which will become
1 minus
5/2 minus 1/2 is,
4/2.
which becomes just what?
5. Wait, 4/2 just becomes.
4/2 is just 2.
Yeah.
Whoa! Do you see it? Look, keep your eye on the right side. Did we get something we need on the right side? Do we have a sine 1/2 x
Yes.
right here, right?
Mhm.
Now we have cubed. We only have 1 here.
Yeah.
So this guy, can we turn this guy into a cosine? Look at your identity.
Yes, 1 minus cosine squared.
No. Check it again. What does 1 minus sine squared x become?
Oh, cosine squared.
Right. So this would become cosine squared x. And then if you multiply that times that, how many cosines do you have are being multiplied? This times this.
3.
Yes. So we got it. Cosine cubed x times sine 1/2 x. Ta-da! And yeah, you can turn that back into a square root symbol.
Mhm.
And we're done. Okay, see it? So
Yes.
how many different methods do we learn? We learned the common denominator method, right?
Yeah.
And then we learned the split the common denominator what?
Into 2.
Yeah, into 2. And then we also learned that on a fraction bar, as long as everything's being multiplied, you can move it up and what?
Up and down.
Yeah,
Just not.
instead of doing the 1 over sine
Yeah,
or
1
whatever,
over
you can
sine.
just, yeah. And then you just rearrange everything and make it look like the other side. Here, we learned that you can actually even factor. And then, again, notice, if you don't recognize this, you see how you can get stuck?
Yeah.
You should be able to get used to this. Oh, this is cosine squared what?
Cosine squared equals
Yeah,
x.
so you should immediately recognize that becomes that. Okay?
Okay.
All right. 17. Here we go. All right. Okay, so what do we do with this guy? Well, again, what side should we start on?
Probably the right side since there's two.
Yes, so we always like to go from fraction to one fraction, right? Or two fractions to one fraction. Now the
Yes.
question is this, what denominator are we going to use? Well, in this case, right now both of them are on the top. Which one should we bring down to the bottom? The sine x or the cosecant x? Take a
Probably
guess.
the cosecant.
Well, okay, if you bring the cosecant down, which I think we can, but look at the left side. This is like, none of these have, what do you call it?
Simplified.
Like they don't have a sine. They don't have sine or cosine, right? It's all like secant stuff.
Yeah.
So I'm thinking because of that, let's keep this cosecant here and turn that into a cosecant, right?
Okay.
So let's try this. So this will become cosecant x minus 1 over cosecant what? Okay, did you write that?
Yes.
Okay, now go and do your common denominator and tell me what you get.
Okay. I got cosecant squared x over cosecant minus 1 over cosecant.
Good. And then can you combine the two?
Yes. So cosecant squared x minus 1 over cosecant x, which is secant squared minus 1. So cotangent squared. So cotangent squared over cosecant squared.
Yes. You already, yeah, you turned that into a cotangent squared?
Yeah.
Nice. Okay, so good. All right, now, so are we almost there? Well, let's see. I think we are because look, in the beginning, we had two different terms with two different denominators. We combine it, now we have like a similar fraction. One fraction here, one fraction what? There?
Okay.
Now, all we have to do is just literally move the trig identities up and down and start canceling until we get a secant on the bottom and a tangent on the what?
On the bottom.
Now watch this. So this is why you want to keep your eye on the goal. You want a tangent on the bottom, you have a cotangent up here. Can we just bring that to the bottom?
Yeah.
So now hold on. But this is a square though, right? But this is not a square, huh? So let's split this into tangent. So
okay.
like this, tangent x. So at this moment, we're just like, doing the Rubik's Cube, like flipping things around, okay? And cosecant x, and then let's bring this guy to the what?
To the bottom.
Oh, wait. Oh my gosh, I'm so dumb. I put tangent. It's
okay. Cotangent, right? Okay.
Okay, so if I take that guy, this one, and bring it down, it becomes tangent what?
Tangent.
Yeah. Okay, so that's done. I got a tangent x, right?
Mm-hmm.
So now the rest have to somehow cancel out and become a what?
Secant. So cotangent,
well,
secant.
Yeah, now can you see it? It will simplify out. So let's take cotangent and unpack it to cosine over sine. You get it?
Which one? Sorry, the cotangent?
This one right here. So
okay.
I'm going to do this in blue. So this cotangent x is going to now become cosine of x, sine of what?
And sine of x.
Yep. And then I'm looking at this, I'm like thinking, whoa. You see this cosecant x right here?
1 over sine?
Well, no, if I take, so it's on the bottom right now. If I move it to the top, it'll cancel with this guy out.
Okay.
Wait, do you get it?
I just keep thinking it as like 1 over sine. So then, like, I know it works, but it gets confusing.
Yeah, you have to increase in your faith.
Yeah.
You have to believe that it's okay to do this. You're like, no, Okay. Yeah, but I told you, if you do the 1 over, I mean, you can. It'll just make it more complicated. You know, like you have like a 1 over tangent kind of stuff.
Mhm.
Okay. Now, this cancels out. And guess what? Look at the left side. I need a secant, right? On the bottom. So just
Mhm.
move the cosine back down, right? So I'm done. Or we're done. Okay, so this one is an example where it's just like rearranging it until it becomes what we want it to become.
Yeah.
So you should like rewatch this part again, I guess.
Okay. Yeah, I already put a star on it so I can redo it later.
So yeah, so again, keep your eye on the goal and try to get whatever it is. Like I was targeting tangent first, right?
Mhm.
Because I know I can take cotangent and bring it to the what? The
Down.
bottom? Yeah.
Yeah.
But then I realized since it's squared, I have to split the cotangent into two separate cotangents because I just need one. And then the
Mhm.
rest just kind of cancels each other out. Okay. 19. Okay, here we go. Here we go. So what side should we start on?
Maybe
Well,
the one on the left.
yeah. So most of the time it's going to be two fractions and get common denominator. Now, the question is though, what common denominator do I want? Well, this is where you can peek on the right side and look at that and go, wait a second, isn't that basically 1 over sine alpha cosine alpha?
Yeah.
Okay, you see it?
Mhm.
So doesn't that give it away? That was the common denominator.
Yeah.
So over here,
Later.
how do we make this into like sine and cosine? Well, cotangent is cosine alpha over sine. There's my sine, right?
Mhm.
And for
And
tangent, it's sine alpha over what?
over cosine.
There it is. So now we have those two common denominators there, right?
Yeah. And then
Okay, so
multiply.
try it. Get your common denominator. Yeah, multiply the denominators together.
So it would be sine theta, cosine theta on the denominator, and then cosine squared theta times or plus sine squared theta. But you can't cancel it out, right?
No. Remember, when you're adding subtracting. Well, here, did you write it as one fraction first?
Yeah, I wrote it as cosine squared theta plus sine squared theta.
Okay, now see, you should recognize this. Do you not see this? What is
The
this?
cosine squared theta.
It's like the most basic Pythagorean theorem identity.
Is it the
Look at the chart. Look, did you write that?
minus b squared? Oh wait, sine theta.
All right, I'll show you. It's right here.
Oh, okay. I need to put
It's
it
what?
just one.
Yeah, so anytime you see a sine squared theta plus a cosine squared theta, it always equals 1.
Okay.
So, see it? Now it's 1 over what?
1 over sine theta times cosine theta.
And are we done?
Yes. Oh, wait.
Well, we have one more step. What's that step?
Just convert it back to cosecant theta.
Can you move it up? Can you move it up by yourself?
Yeah, cosecant theta and then secant theta.
Well, this one is technically alpha, but yeah, it's okay.
Oh yeah, alpha.
It's a fish. Okay, so cosecant theta, secant theta. Okay. All right, so imagine you got here on the test and you totally forgot that this right here is your identity, which is equal to what?
To 1.
And you're just like pulling out your hair. So really get used to those that chart, okay?
Okay.
Yeah, really try to recognize what's on here. Then it makes things a little bit easier. Okay, 21.
Okay.
Okay, this one is insane. This one is insane. Like it's so hard. Like, okay, try it.
Okay.
Try it. What would you do? What would you do? What would you do? What would you do?
Start on the one with the two fractions,
Okay.
and then
What are we gonna do?
so 1 tan is equal to cotangent. So you convert that.
Wait, say it again.
Oh, do you just convert it like 1 over tan x is equal to cotangent, and then 1 over cotangent is equal to tan. So it's just becomes the same.
And we're done.
Yeah.
I was just kidding. This is like the easiest one.
Yeah. And hopefully there's going to be at least one of these on the quiz. I think there was it was really hard, but I can't remember which one it was.
I think it's 23. This one took a whole page. Look how long. Well, I tried 2 different ways, and this one, yeah, look at this. This is 23 right here.
Yeah, that's very long.
Now, if you have a shorter way, I'm happy to learn. But I did it 2 separate ways. I still got the same answer. You see this?
Mm-hmm. The cosecant.
Yeah. But this one was long, like insanely insane. Like it was just insane. So
can we do 27 maybe?
Okay.
I don't know why, like the pi over 2 confuses me kind of.
So remember, go you do you blah 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 blah. Do you recognize that that's the cofunction thingy on that chart?
Oh yes. Okay.
Okay, look. What does tangent pi over 2 minus u equal to?
Cotangent.
Cotangent u, right? So
yeah.
What is this equal to right here?
Just cotangent.
Cotangent theta times tangent theta equals 1. And isn't that 1?
Yeah.
Because this is 1 over tangent, right?
Yes.
Your
So
favorite? Yeah. There. So you have to memorize these. I know, you're like, no, but you have to memorize it. All right,
okay.
We'll try 29.
Sure. 29. Yeah.
Are you hoping that Miss Talent's not going to put that long one on the quiz?
I hope not. I think she said she's doing 1 easy and then 2 medium and then 1 like difficult problem, but she didn't say like what it would be like.
What if that was the difficult one? Oh. Okay, so this is just use the chart. What's cosecant negative x?
Cosecant negative x over cosecant negative x is cosecant negative x. Would it be cosecant parentheses?
No, negative cosecant x.
Oh, so would it just be negative cosecant x?
Yeah. So you want to pull out the negative from the inside and rewrite it like this. That's the goal, because the right side doesn't have a negative x, right? In the denominator, secant negative x becomes what? Just secant of a negative number is the same thing as secant of the positive what?
Positive number?
Yeah, based on the chart. Now I'll explain like the intuitive aspect, but for right now you just have to memorize it. Right here?
Yeah.
See this? I mean, yeah, wait. No, this one. This one right here. See this? Oh, no, that's cosine. This one. Secant of negative u equals secant of u.
Okay, so those are both positive, right?
Yeah.
Okay.
Okay, so now, okay, look, watch this. You're taking a look at this, and you're thinking, all right, so remember, your goal is to get to the other side.
Yeah.
Right now, we have negative signs. That's a good sign, right?
Mm-hmm.
But you're thinking, where did the cotangent come from here? Now watch. Before you write anything, try to do some of it in your head. isn't cotangent cosine over sine?
Yes. Cosine over sine.
If you move, look. If you move this to the top, wouldn't that be cosine?
Secant over, yes, because it's like the opposite.
And then if you move cosecant down, it'll become
Cosine. Wait,
sine.
cosecant. Oh, wait. Yeah, cosine. Okay.
All right, let's try that one more time. So I'm looking at this. I'm thinking, hey, isn't that cosine over what?
Cosine over sine. Yeah.
And I'm thinking, where am I going to get cosine from this? If I move secant back to the top, it'll become
Sine. Wait, no, cosine.
cosine. And if I move cosecant down, it'll become
Sine.
sine. Okay, do you get it?
Yeah.
So this will become cosine of x over sine of x, which becomes negative cotangent of x. After this, I'm going to go hunting for a skunk in my backyard. I have a trap. I got to set it up. Oh my gosh, I hope I don't get sprayed. Okay. Did I tell you my dog got sprayed by a skunk right on her face?
Oh, no.
Right on her face. All right, 31. You know what? I think if okay. I'm going to make a little wager. I think this might be on there as the hard one.
Okay.
Because this is not as hard as the other one, but
Yeah.
it's quite lengthy. Okay. All right. So let's try this. Now, so which side should I start? Now, the left side definitely looks more dense, right?
Yeah.
But I'm looking at this, I'm thinking, wait a second. Everything on the left side is sine and cosine. Tangent is made up of sine and what?
Sine and cosine.
So it must gone from that to what?
To the left
To
side.
that. So here it
Okay.
goes. All right. So tangent x will become sine x over what?
Over
Cosine of
cosine.
x. Plus sine of y over cosine of what? Right, you see that?
Yeah. Sorry, I'm
Yeah.
just trying to
Now
remember.
get all the make sure you get all the x's and y's like really like precisely written, or else you'll mess this up. And on the denominator, this will become sine x cosine of x, sine y over cosine of what?
Cosine of y.
Okay, see it? All right. Now again, you got a bunch of fractions. Yeah, fractions on the top, fractions on the bottom. So we're gonna get common denominator on the top and the bottom simultaneously. So the numerator, I'm going to write this as cosine of x, cosine of y. And, well, actually, no, here. Let me do it carefully so that you'll see what's going on. So this will be like this. Cosine of x, cosine of y, cosine of x, cosine of y. And then on the numerator, this will become sine x times the cosine of y. And this will become sine y times cosine of x. Okay, you following?
Are you multiplying the cosine y? Is it just coming from the denominator?
Yeah, so the numerator up here is both of those together, right?
Oh, okay, because it's not okay, it's addition. Oh, that makes
Yeah.
sense.
Yeah, exactly. And then you just get equivalent fractions.
Yeah.
And then this one, well, let me use a different color. So become cosine of x, cosine of y, cosine of x, cosine of y. And then the numerator will become cosine of x, cosine of y. The second one just stays the same. Sine of x, sine of y. Okay. So there it is. I know it looks pretty messy, but it's just fractions written in a very like dense kind of way. Okay. So the numerator.
Where does the one? Is it the
right here? This one became this.
1 minus? Oh, okay, because you did it
the
over.
Denominator, yeah. You see that?
Yeah.
Okay, so the denominator is going to be like this. cosine of x, cosine of y, cosine of x, cosine of y minus sine of x, sine of y. The numerator be this. It's cosine of y, cosine of x. Okay, almost done. So it's just a lot of work, but it's not that complicated. You're just getting common denominators and trying to get one fraction on the top, one fraction on the what?
On the bottom.
Yeah, like this. You see it? Okay, how far are you? Are you here?
I'm working on the numerator right now.
Okay, so I'll wait up until you get to this point.
Okay. Okay.
All right. So what do you do from here? We're going to take the denominator and we're going to what?
Multiply by the reciprocal?
Yes. So the numerator will become sine x cosine of y plus sine y cosine of x all over cosine of x cosine of y times dun, 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 dun. Do you see something's going to cancel out? Do you see it?
Yeah, the cosine x and the cosine y.
Yes. Cancel, and your final answer will look just like the left side, right?
Mm-hmm.
Sine of x cosine of y plus sine of y and cosine of y. Oh, wait, cosine of x all over cosine of x, cosine of y, sine of x, sine of y. Wow. Okay, I mean, that wasn't that hard. It's just common denominators, right?
Yeah.
Fractions. Here. Which part do you want me to show you? This part?
think oh yeah, I did it correctly. And then I need to remember that I can't like cross it out more when it's adding. I think sometimes I just think I can't.
Wait, you mean like this? Like that?
Yeah, I didn't actually do it, but like my brain is like it's like thinking of doing it, if that makes sense.
Don't.
Yeah.
Just hold yourself back. Okay, so yeah, make sure you don't do that. Again, so that's why you want to keep your eye on this side. You want to peer over and ask, am I heading into that right direction?
Yeah.
Because you might just keep going and not, like, you can actually go right past it, you know?
Mm-hmm.
Okay, so that's 31. You have to do up to 33?
I mean, I already did all of them, but like there's some of them that I was a little confused on. I think I'm gonna try finding the problem. I remember there was one of them that she said was like the hardest one. Oh, okay. This number, yeah, 31 was the one that she said was like one of the harder ones, I think. And then maybe 35.
Wait, isn't it only up to 33? It's up to 35?
I think it is up to 30. Actually, yeah, I think it is up to 35. Let me double check.
Okay, now here, let me show you this one. This one's pretty cool, I think. Yeah. Okay. Can you do this in one step?
Okay,
Or two steps? Two steps. So, which side would you start on?
The one with on the right side?
Yes, but remember, usually, right? Usually we'll start on the right side, but here, can you split the fraction?
Yes, so tan x over tan x over cotangent y, and then plus cotangent y over tan x of cotangent y.
Cancel. You can cancel on, right?
Both sides, yeah. So
Nope.
1 over cotangent y plus 1 over tan x. So it's equal to, okay, so tan y plus cotangent x.
There you go. Got it?
Yeah.
So look out for these, okay?
Okay.
All right. 35. Let's see, we have a minute.
Oh yeah, 35 might be a little bit too long then because it's. I think it's mainly just like the square root.
Okay,
Yeah.
I'll just quickly show you how to do this. This would be a situation where you'll multiply by the what do you call it? The conjugate. So what you want to do is basically take the denominator and multiply by the opposite, 1 plus sine theta, like this. You see it?
Yes. So 1 plus something.
That. Okay. And what's going to happen is that the numerator will get 1 plus sine theta like squared, right?
Yeah.
Over, and the denominator will become 1 minus or sine squared what? Theta?
Theta.
Now the square root of a square is just itself, so that's 1 plus sine theta. The denominator, this guy, do you okay, you should recognize it now. 1 minus sine squared theta becomes?
Is it the
cosine squared theta.
Okay, cosine squared theta.
And then what's the square root of that? Well, it's plus or minus what?
Cosine?
Yeah. Now, whenever you do a plus or minus, you have to give it a absolute value. Okay.
Oh, okay.
That's what that is.
Oh, okay.
But my question is, why didn't they do on the top? Why did they just do it on the bottom, huh?
Yeah.
Well, I think it's because 1 plus sine theta is a positive number. And so, but the 1 minus idea can produce a negative number. So that's why I think they did the plus or minus. So anyways, that's how you do this one, okay?
Okay.
All right.
Sounds good.
Okay, I think that's it for today. Have a wonderful weekend. Study hard. Okay, so I'll send you both of you and Adeline both links, so you can just kind of, scrub through it and use what you need. Okay.
Okay.
All right. Have a good night. Bye.
Thank you, you too.